numbers to start with. So we're just using this space we have here on page 87 to just divide two numbers. Let's make it pretty simple. Let's say we want to divide 31 by 4. I can use long division to do this. The way I can do it is I can say 31 divided by 4, like this. I say how many times does 31, can it get divided by 4? What's that going to be? 7, and so then we would multiply. 7 times 4 is 28. And then what do we do next? Subtract. And so the way I would write this answer would be 7 3/4. I know a lot of you were taught to put the decimals after it, but we're not going to do that. We just want to have it written as a fraction remainder. So that's kind of our process for this. What we did was we divided, then we had to multiply, then subtract, and then we had to bring down a number if it had been necessary. Like if there had been another digit here, like suppose there had been a 0 here, it would have been 310, let's say. Well, then I would have to keep going, and I would have had to have brought down the 0, and then I would have divided again, and I would have gotten 7. 7 times 4 is 28, and then I would have had this answer here, 77 1/2. But that's the process we use for long division. It's this same thing over and over. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So now we're going to look at how we would do this with some other kinds of problems using polynomials. So now let's look at page 89. I'll just ignore this. I'm not going to do that one. And look at number 1. So here's what I'm going to do to divide this. This is what I'm dividing by, x minus 3. And this is what I'm dividing into, x squared plus 6x plus 12. And the way that we said that we do it is we divide, multiply, subtract, bring down. So the first thing we have to do with polynomial functions when we're dividing is divide. So I just look at the first values. So what is x squared divided by x? X. So I put an x up here. The next thing I do after I divide is I have to multiply. And so I'm going to multiply x times x, that's x squared. X times -3, that's -3x. What's the next thing we do after we have multiplied? Subtract. So I have to subtract this whole thing. So I have to subtract this and this term. I have to subtract the whole thing. That's where people usually mess up, is that they forget that they're also subtracting this term. So it had to turn into a plus because it's minus a negative is a positive. So this is 0, this is 9x. Then I have to bring down the 12. So I just brought down, so now I go back up, and I have to divide again. When I divide, I only look at the first values. So what is 9x divided by x? 9. And now I take what I just put there, and I have to multiply. So 9 times x is 9x, and 9 times -3 is -27. And now what do we want to do? After we've multiplied, we just multiplied, what do we do now? Subtract. So I'm going to subtract the whole thing. So I have to subtract this one, and I have minus a negative that I had to subtract. So this is going to give me 37. So our answer for this would be that our answer was x plus 9, that's our quotient, plus we had 37 over what we were dividing by, over that divisor. And that's the answer when we divide that out. So the only difference is now we have variables instead of just having numbers. Yes, I'm sorry. Yep. Thank you. Anybody else have questions? All right. Let's do another one then, because you really need to see this a couple times to get the hang of it. Let's look at number 3. So here's what is going to get divided. So we have x to the third plus 13x squared plus 27x plus 6. Here's our divisor, 4x plus 1. And we're just going to use that same process, divide, multiply, subtract, bring down. So we're going to start off by dividing. So we're going to have 4x to the third divided by 4x. What's that going to be, Abby? X squared, right. So we have x squared, and now we have to multiply. So when we divide, we just look at the first values, but when we multiply by the whole thing. It's kind of like the same thing you do when you're doing long division with numbers. You use the first numbers to kind of estimate, but when you multiply the whole thing. So x squared times 4x is 4x to the third. X squared times 1 is 1x squared. Now what, Joey? Subtract. So I have to subtract the whole thing. So these are 0. This is going to be 12x squared. What else do I have to do? Joey? Bring down. Okay, so now we're going to go back and we have to divide now. So Drew, what's 12x squared divided by 4x? What's that going to be? So I'm going to have 3x. Now when I multiply, I just multiply what I have right here. So I've got 3x times 4x is 12x squared. 3x times 1 is 3x. After we've multiplied, we now have to subtract. So I subtract the whole thing. That's 0. This is 24x. And I have to bring down. And now I have to look at it and say 24x divided by 4x. What's that, everyone? 6. I have to multiply. 6 times 4x is 24x. 6 times 1 is 6. Subtract. And what are we left with when we subtract? 0. So therefore, this is going to be the entire quotient. There was no remainder. If I wanted to, I could check this by seeing if these two multiplied would equal that. We're not going to check it though, but you could. Okay, let's go over to that space where you have some room where it says notes on page 88. And let's do another problem, one that has some different things to look at. So let's look at this. So let's say we've got x squared minus 1. And I'm going to write it like this first. Let's say we've got 2x to the 5th minus 3x to the 3rd plus 2x minus 4. And we're going to divide that by x squared minus 1. Here's what I want to show you. It doesn't matter that this is x squared minus 1, that's fine. But this one is going to be a bit of a problem because I'm going to have to put 2x to the 5th, but I don't have an x to the 4th term, so I'm going to put in a 0x to the 4th. The reason why is because I might have to subtract from an x to the 4th. What else am I going to have to put in there? Right, I'm missing an x squared term, so I'm going to put it in there just in case. We may not need it, but we might. Now I'm going to do this one a little bit faster, and if you just want to watch instead of copying it down, that's totally fine, if you just kind of want to watch. Okay, so I'm going to have 2x to the 5th divided by x squared. That's going to give me 2x to the 3rd. When I multiply, I get 2x to the 5th minus 2x to the 3rd. Do you notice how I lined those up? I didn't want to put it here because it's not going to be a like term, right? So I just did that instead. So now I have to subtract. So when I subtract this, I have nothing. Here I have nothing. I really didn't need that, but I didn't know ahead of time. This is going to give me a negative 1x to the 3rd, and I'm going to go ahead and bring this down. I might need it, I might not. So now I have negative 1x to the 3rd, and I'm dividing that by x squared. What's that going to be? Just what? Negative x, so I'm going to put a negative x up here. Now I have to multiply. Negative x times x squared is negative x to the 3rd. Negative x times negative 1 is going to be a positive 1x. Now I have to subtract. This I don't really need, but what am I going to have to do? I have to bring down this 2x. See, the reason I need to bring down the 2x is because I need to subtract it, right? So I have to subtract it from whatever it's alike. So now I have a negative 1x to the 3rd minus a negative, that's 0. I have a 2x minus a 1x, that's going to be a 1x, minus 4. Now, can I do 1x divided by x squared? No, I can't. So that's how I know I'm finished. So this answer is going to be 2x to the 3rd minus x plus x minus 4 over x squared minus 1. Okay? Do you understand the process there? Like, not every problem is everything going to line up perfectly. Sometimes you have to put in the zeros. Sometimes you may not use the zeros after you put them in. But a lot of times you will need them. All right, here's what we're going to do next. I want to show you another method. It's called synthetic division. Synthetic division looks like this. You're going to have a linear divisor. This only works for linear divisors. When I say linear, that means x to the 1st. So you have to have a linear divisor. And then whatever makes the divisor equal 0, that's going to go in a little box like this. And then you're going to use the coefficients, and they're all going to get lined up. And then it's going to be this process where you're going to bring down the first number. And then all you have to do is multiply and add over and over. The first time I do this, it might seem a little confusing, but it's so much easier than the long division I've been showing you once you get the hang of it. So we're going to do the same problem that we did just a minute ago, this number 1, but in this open note space. We're going to do it right here. X squared plus 6x plus 12 divided by x minus 3. That was the problem we already did. I just want to show you how to do this problem with synthetic division. I have to check my divisor. Is it linear? Is it just x to the 1st? Yes. What is it that would make this divisor equal 0? What value? 3. 3 is going to go in a box, just like that. Now we're going to use the coefficients, like I said just a minute ago. So what's this coefficient? 1, and then 6, and then 12. So the process goes, all we have to do is bring down the first number. Bring it down. And now you're just going to multiply. So you're going to do 1 times 3 is 3. Then what did I say you do with these? Add or subtract? Add. So 6 plus 3 is 9. As soon as I have a number here, I have to multiply it by that. So 9 times 3 is 27. And then what do I have to do with these two? Add. And I get 39. So look at the answer that we got before. The answer that we got before was x plus 9 plus 39 over x minus 3. Can you see how that's really, this is telling us what the answer is? See, we were doing x squared divided by x. So therefore, this is my x term. So I know my answer has to be 1x, or just x, plus 9, and then this number right here is always going to be the remainder. So my answer is x plus 9 plus 39 over what it is I was dividing by. That's going to be the answer right there. Okay? And that is going to be so much faster than doing it the other way once you get the hang of it. So, questions, Joe? It's whatever makes this equal 0. Whatever makes the divisor equal 0. Let's do another one then, guys, and I'm sure it'll make a lot more sense as we go on. Let's look at number 5. Here's where we look first. What makes that equal 0? 2. 2 goes in the box. We list our coefficients. 1, negative 10, and 2. We bring down the first number, 1, and then we just have to multiply. 2 times 1 is 2, and add. 2 times negative 8 is negative 16, and add. This right here is our remainder. We look back at how we were dividing. We were dividing x to the second by x. So therefore, this has to be 1x to the first minus 8 plus negative 14 over x minus 2. Does that make sense to everybody? All right. Let's do this next one then. And Risha, what's going to make this equal 0? So negative 2 goes in the box. Baxter, what are my coefficients?
1, 4, 6, and 4.
Good. Mitchell, what's the first thing we do? Jake, what do we do now? So we get negative 2, and now we add, we multiply, we add, we multiply, we add. Now we're going to check this and look at the fact that we have x to the third divided by x. So what power must this be? Not x this time, this would have to be x to the second. So our answer is going to be x to the second plus 2x plus 2. The remainder was 0, so I don't even have to write anything else out. That's the answer if we divide it. Questions? Okay. Let's look at this one because I want to show you something with the setup. We're not even going to actually do this one, but I just want to show you the setup. First of all, what makes this 0, everyone? This is what I was talking about if we're missing terms. Can anybody tell me how the coefficients here would have to go? 2, then what? 0, 0. So I need another 0. This is x to the third, x to the second, x, and then just the negative 54. That would be the setup. See how it goes? 2x to the third, 0x to the second, 0x, and then minus 54. I'll do it real quick. You don't have to copy it. Just watch. 2, that's going to be negative 6. That's negative 6. That's 18. That's 18. That's negative 54. That's negative 108. It's going to be 2x squared minus 6x plus 18 plus negative 108 over x plus 3. That's how quick I'd like you to get to where you can do it just like that. Okay? All right, you guys try this number 8 then on your own. How are you going to do it? Did you get it right? I had a little mistake right in here, so you do want to make sure that if you do it quickly, go back and check it and just make sure you don't make a little mistake with your signs or anything. This one I ended up with a 0 as my constant term, so I don't really have to write plus 0. But this number right here at the end is always going to be the remainder. So 4 is going to be the remainder. Did anybody miss it and want us to look at it? We can find your mistake. Okay. Let's go over to the back now. So this is the whole reason why synthetic division is helpful. We're not going to do the top with the matching, but you could do this pretty easily. If you just use synthetic division on these, you could find the remainder very quickly, and you would know what the answer is. See how quick you could do those if you needed to. We'll go back and do those after we finish. But for now, I want to come down here. And the whole reason why we like to use synthetic division is because the remainder is equal to f of c. So what we're talking about is, this is my c value, this is my value that I'm going to put in, and whatever I get for my remainder, it's the same thing as if I plug this x in, if I plug this c value in. In other words, I could go through here, I could do 2 to the third is 8 times negative 3. Watch, I'm going to do this pretty quickly. 2 to the third is 8, that's going to be negative 24. 2 squared is 4, times 4 is 16. Negative 17 times 2 is negative 34 minus 6. What is that? Negative 58. 16 minus 6 is 10. The answer should be negative 48, I believe. I could have even made a little mistake in there. But look, if I use synthetic, I can put my 2 in the box. Now, I don't have to say what's going to make this equal 0, because they're already telling me x equals 2, so I put 2 in the box. Then I'm going to use my coefficients, negative 3, 4, negative 17, and negative 6. I bring this down, negative 3. That's negative 6, I add. That's negative 4, I add. That's going to be negative 42, and I add. And right here, that remainder is the answer to if I had plugged in 2 for x. That's such a helpful thing, because I can do synthetic division faster than I can actually plug in 2. And I wasn't even real confident when I plugged in the 2. I was afraid I might have made a little mistake. But with the synthetic division, you can get it done much quicker. Okay, so let's do it now for 14. Remember, they're already telling us our x value, so we don't have to set it equal to 0 anymore. We use the coefficient, negative 1, 0 for x to the third, 1 for x squared, 0 for x, 4 for the constant. Bring it down. Negative 1, that's 1, add. That's negative 1, add. That's 0, add. That's 0, add. And so the answer is 4. Okay? So that's how quick we can do it. Let's have you guys try one. Why don't you guys try number 16 now on your own? Or get 78? Alright, good. Okay, and then the last thing we're going to do is we're going to do this one right here, number 17. This is asking us, what does this value of k have to be in order for us to have a remainder of 0? This is a kind of tough problem. I mean, I could just plug in numbers. I could check if k is 1, does it work? If k is 2, does it work? 3? That would take me forever, though. So here's what I'm going to do instead. I'm going to use this little space here. Remember, this is a linear term. So I want to think, what would make it equal 0? What is that value? 4 is going to go in the box. Then I write my coefficients. -1, 0, 5, k, and -8. Those are going to be my coefficients. So first, I'm going to bring this down, and I have -1. I have to multiply and add. Multiply and add. Multiply and add. Okay, and now I have to multiply this by 4. The whole thing has to get multiplied by 4. So that's actually going to be 4k minus, and 44 times 4 is 176. So I just multiplied this by that, and now I have to add. I get 4k minus 184. And the question is, what does k need to be for the remainder to be 0? So what would we now have to do, guys? How would I solve that? What do I want this spot right here to be? They said I want the remainder to be 0, so this spot is the remainder spot, so I'm going to have to say 4k minus 184 has to be what? 0. So to solve that then, I'm going to have 4k, take over the 184, divide it, and so to divide it, just you can get out a calculator if you want, but hopefully you don't even need a calculator. To divide it by 4, I can just say 4 goes into 18 4 times with 2 left over. 4 goes into 24 6 times. So therefore, if k equals 46, that's going to make us have a remainder of 0. Okay? What questions do you have? So we looked at 3 things. Polynomial long division. That's where we have to do long division just like we would do with numbers. Synthetic division, where we just bring down, multiply, add, multiply, add, multiply, add. And then the last thing we have to know is that that remainder is actually the same thing as if we were to plug in that value into the function. Those are the 3 big topics we learned. Okay, so you guys need to do the assignment that's on the board. It's also on Canvas. It's not the same as what's on your assignment sheet. I changed it just a little bit. Number 9 is a difficult problem. I'd love for you to get through number 9 before you go, just because I want to make sure that you can do that polynomial long division on your own. Okay?